So hi, this is Mike. Mike, would you mind introducing yourself for just like your background?
Yeah, sure. So I'm Mike Rohde. I'm a designer and author and an illustrator. Long time doing design work, all the way from print design to web design, and now currently in user experience design. Work on software products to make them easier for people to use. As an author, I've written two books, the Sketchnote Handbook and the Sketchnote Workbook, to help people do visual note taking, which I call sketchnoting. And those have been selling for 10 plus years, continue to sell, and then I speak and teach around that topic. And then finally, illustrator of the books Rework and Remote, the $100 Startup, Honest SEO, and others, using a distinct, very simple, clear, and often humorous style to communicate ideas for authors. That's me.
Awesome. So we can jump right into the demo. So for context, we had a call. Me and Mike had a call where we introduced the technique a little bit, but we haven't actually gotten into the rigorous demo. Mike, I just sent in the chat a YouTube link. Go ahead and open this link and then share your screen.
All right. Let me go to that. I'm going to separate that tab into a separate tab. I'm
Good call.
pausing the video. Let's see. And let me share. I got to find there we go. And I think I want to share a window or screen. I don't think it matters, does it?
No, not really. Window, it's just going to share that. Wait, you probably know this.
Yeah.
It doesn't matter.
Maybe I need to drag it back in. I don't know. Here, let's try this again. This is exciting video, everybody.
Yeah.
So here.
The thing is that like on the website, right, we offer a demo, and we have like the protocol for the demo, but people are still like, what does that look like in real life? So hopefully this can actually show like a real life version of what people sign up for that hour. Okay, you can pause the video.
Yeah, I did.
All right. So the first step to using the Atlas technique is going to be picturing your hometown or a place you know really well. And try to start with a specific place. So it could be your house.
Okay.
Maybe, okay. Tell me when you got it.
I've got it.
Okay. Where is it?
So it's a village called Menominee Falls, northwest of the city of Milwaukee. That's where I live.
Okay, awesome.
Yeah.
Okay, so it sounds like you're sorry, I was vague in the question. Your hometown, I'm guessing, is or
Yeah,
your current town. Gotcha.
yeah,
Okay.
it's where I live. My hometown would be
Okay.
a different place since I was born elsewhere, but I think for the
Gotcha.
purpose
Yeah,
of the demo,
this works.
where I
Um,
live.
sure. What you're going to do during this video is a three-step process.
Okay.
The first step is watch the video until you understand something, like the author has said a complete idea. Then
Okay.
you are going to take the visual that the author presented and you're going to create that 3D model in your place that 3D model on, let's say, your table in your house.
Okay.
Now, so far, this is kind of like the Mind Palace. Here's where we introduce dual coding. You are going to, while picturing the 3D model that the author has presented to you, simultaneously while picturing, you're going to use your voice to describe how this mechanism works. And I say mechanism because it's actually going to describe how a pin tumbler lock works.
Yes. Yeah.
So the steps are watch a little bit of video, then place the 3D model, and then describe how this thing works. And that's
Okay.
actually the 3 iterative steps of every time you're going to encode information in the Atlas. So what we can do is you can unpause the video in a second, and then
Okay.
you'll watch a little bit. I've seen this a couple times before, so I know when the video like gets to a complete idea. I'll tell you when to pause. So you can
Oh,
unpause,
got
watch,
it.
and pay attention, and get ready to pause again.
Got it. So I will not watch the whole video, just a portion of it. Okay.
Correct.
That was
Yeah.
my only other question I had for you. So great. We're all ready. I can hit
Yeah.
play. All right, here we go.
Actually, can you pause it for one sec?
Yeah, sure.
Can you turn on captions?
Oh yeah.
Oh, captions are on. Oh, oopsies. Okay, you're good.
There weren't any captions. By
Yeah.
the way, Paradone is great. I know his stuff, so he's excellent.
Oh, great. Nice. Have
Yeah.
you actually seen this video before?
No, I haven't seen this one. I've seen he's
Okay.
deconstructed like the Titanic and explained it
Yeah, yeah.
and the
Uh-huh.
ISS. So I've seen his work before, but not the specific video.
Okay, great.
I have
Awesome.
no
Yeah, you,
I
you
have
can.
one. All right, here we go. Playing again.
Okay. Okay, you can pause here.
Okay.
So, the first step is choose a space, choose a place where you're going to put this.
Okay, got it.
Okay. Now take a mental picture of what you see on the screen, like this 3D model. Something that might help is look at it, close your eyes, try to remember as much of the picture as you can, open your eyes, look at it, try to remember as much of the picture as you can. Do that a couple times, and then you'll notice after about a couple times, you'll just be able to build this pretty much like perfectly on your kitchen table or wherever you're putting this.
Okay. I've done it 3 times now, so I'll do it one more time.
Sure.
All right. So I've done it 4 times. That seemed like a good amount of time
Yeah.
to have been close my eyes.
Great.
And
And now place this 3D model on
okay.
your kitchen, yeah, wherever you were doing it. What specific object are you placing this on? Is it like on a table? Um,
Yeah, in our kitchen we have like a kitchen island.
okay,
Got like a stone top on it, which we all sit and
perfect.
eat.
Yeah. Okay,
And I'm sitting at the end of the table, imagining myself looking toward the wall. There's a clock up on
awesome.
the wall, and then
Nice.
I'm hanging this image of the case and the plug and the springs and
Okay.
the.
Yeah. This is
Um,
actually a tricky one. Did you build it as an image or did you build it as a 3D model?
I was building it as a 3D model. I was imagining it floating over
Okay,
the
perfect. Yeah,
table with.
that's great. Okay, nice. So when you're watching a video, uh, your first step is to build the 3D model, and then you would do the voiceover. Also, in this demo session, we're going to go pretty slow, because you're learning. But typically, how you execute this technique is in real time or at like 1.25x speed. You can actually watch me do the type of task you're about to do, which is watch videos in real time and then reason about them. You can watch me do that with like 22-minute, super complicated lectures all in a row and then reason about like 16 things on YouTube. But for this demonstration, you're learning, and so we'll pause.
I would
Okay,
just like anything where you start slow and get the technique down, and then start
there you
speeding
go.
up down.
Yeah. Okay, so you can unpause, and then I'll tell you when to pause again.
All right.
Okay, you can pause.
Interesting.
Okay. So the author has just explained how this 3D model in your head works. Now, what you're going to do is, while visually focused on the 3D model you have, you are going to talk out loud. And you could do this in your head, but just for the sake of me being able to make sure you're doing it the right way, and for the video, it's helpful if you talk out loud. So while you're visually focused on this 3D model, you're actually going to describe to yourself how this mechanism works. So I'll give you a demonstration of what that might look like. Um, I'm visualizing my tumbler lock, which I've watched this video a couple times now. So I already have this, but I'm going to pretend like I haven't. Okay, so I see the springs are pressing all of the pins down. So they're in this down state initially. And if you actually look into the keyhole, you just see pins. You're not able to tell the full height.
Yeah.
And the pins are all at different heights. So when the actual correct key goes in, it pushes all the pins up so that it hits the shear line. And you can actually rotate it because there's nothing actually connecting the rotatey part to the full part. So that was my understanding of how this mechanism works. And that whole time, I was visually focused on my 3D model. So you can
Okay.
give it a shot.
So I would think because this is on the screen for me, a good practice would be to close my eyes and imagine it and not look at what I see on the
Yeah,
screen, so
true.
that I'm reading it in my mind. So I'm sitting at my kitchen table. And I'm imagining this 3D model that I feel like I could spin and turn in any direction. I can slice it just like I saw in the video. And I see the case and the plug and the keyway that's there. I see the key going into it and turning it, and then I'm able to spin it, and then with my hand I slice the image in half, the 3D model in half, and then I can see inside of it. And now I see, I don't know the terms for them, but I see 5 or 6 elements with springs above them that are set in a certain pattern, and that there is a line that, in order for them to turn, that the plug to turn, that the spring would be pressed up by the key, and those elements would be set in a way that they would line up, so that only the bottom portion lines up perfectly, and then that allows the plug to spin, which I saw in the original image, which now makes sense to me, right? Only that key will work because another key would push it up in the wrong order, and then some of those are at the wrong heights, I would say, and it would block that plug from turning.
Great. You did a literal 10 out of 10 on that task.
I don't think I described like the elements I'm now seeing now that I've opened my eyes.
Yeah.
They described what they were, but I don't remember the terms. I would
I don't
imagine
remember the names either.
repeatedly watching them, I probably would understand, but it's an
Yeah.
interesting concept.
Yeah. One thing that is generally true about the Atlas, and especially when I watch videos like this, is I don't remember words for it so well. I usually remember like concepts, structures, how things work. And this is actually a bit of a contrast to the Memory Palace, where typically you'd focus on like the labels. This more gets at, I guess, the conceptual structure. Okay. So we have a little bit more of the video left. You're going to watch it, and then I'll tell you when to pause, and then you'll just do this whole process again, where you'll do a voiceover describing how the next thing works.
Great.
Okay, you can pause here. And this part of the video is a little confusing. You might be wondering, and you might not be, but it might be helpful for the people watching this, um, uh, how that actually works. Because you'd think like, wouldn't you have to have the same exact key? Um, Essentially, the only pin that is different among every room in the building is just the master pin. All the other pins are the same for each key. So you might think like, oh, this actually sounds really not secure, right? Because let's say there are 5 pins, these 4 pins are the same for every single room in the building. So all you have to kind of guess is just the first one, right? But then that's actually why Jared Owen said, the author said, sometimes you have multiple master pins. So that way, instead of just having to guess one pin right, you have to get multiple pins right.
Yeah.
Okay, so your job now is to again visually focus on your 3D model, build what you need to. So you build the master pins and describe how this mechanism works.
Okay. I have not. I'm in my spatial, what I'm seeing here in my imagination. It's in the position it's split just like I left it. And now what I've done is I've added the master pin into and pushed the 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 um the existing pin down a little bit, I think is what happened. And then the spring now holds tension on the master pin and the one below it. I see that the regular key goes in and is actually spinning and working just like it had before. But now the master key goes in and pushes that master pin to the right spot. And now that also turns. And then I see, based on what I saw in the video, that for probably multi-layer security, that there could potentially be other master pins in 2 or 3, or I guess multiple other locations as a security check for additional security.
Great. Okay. And the rest of this video is just an ad. So I'm going to send the next link.
All right.
So this video is actually going to act as the control. I vary these controls in the demo, which one is the control, which ones aren't. So for this video, you are allowed to use any strategy that you know how.
Okay.
You're allowed to pause. I'm guessing you're going to take sketch notes.
Maybe I try sketchnoting.
Yeah.
Kind of have to, don't I?
Yeah, right. So yeah, during this video, you're allowed to pause, you're allowed to take any notes. The only thing you're not allowed to do is use the atlas. So use this 3D model / dual coding approach you just found. Also, I can't see your screen, it's black right now. Are you sharing it?
I think I am presenting.
Mm-hmm.
They show my screen anyway. Now you're going to get the endless share. I think mainly because I have to now. While I was listening, I was not clicking on the video, so you should.
Oh, gotcha. Okay.
We should be now loading.
I still can't see anything.
Back to you. Share just the screen with the video.
Cool.
I think that's what you want, right?
Yep. Yeah, that's perfect.
There we go.
Okay, yeah, you can go ahead and start.
All right, here we go.
Is the process of taking a message and scrambling its contents so that only certain people can look at your message. There are 2 types of encryption, symmetric and asymmetric encryption. Let's first take a look at symmetric encryption to understand why asymmetric encryption was created. To do that, let me introduce you to Alice and Bob. Alice has a sensitive document that she wants to share with Bob. She uses an encryption program to protect her document with a password or passphrase that she chooses. She then sends the encrypted document to Bob. However, Bob cannot open this message because he doesn't know the passphrase that Alice used to encrypt the document. In other words, he doesn't have the key to open the lock. Now comes a real problem. How does Alice share this passphrase securely with Bob? Sending it through email is risky because others might find the passphrase and use it to decrypt any messages between Alice and Bob. This is exactly the kind of problem that asymmetric encryption intends to solve. It is comparable to a mailbox on the street. The mailbox is exposed to anyone who knows its location. We can say that the location of the mailbox is completely public. Anyone who knows the address can go to the mailbox and drop in a letter. However, only the owner of the mailbox has a key to open it up and read the messages. So let's now go back to technical details. When using asymmetric encryption, both Alice and Bob have to generate a key pair on their computers. A popular and secure way for doing this is by using the RSA algorithm. This algorithm will generate a public and private key that are mathematically linked to each other. Public keys can be used to encrypt data, and only the matching private key can be used to decrypt it. Even though the keys are linked together, they cannot be derived from each other. In other words, if you know someone's public key, you cannot derive his private key. If we retake our mailbox example, then the mailbox's address would be the public key, something that everyone is allowed to know. The owner of the mailbox is the only one who has the private key, and that is needed to open up the mailbox. Let's now take a look at how Alice and Bob can use asymmetric encryption to communicate securely with each other. They start by exchanging their public keys. Bob gives his public key to Alice, and Alice gives her public key to Bob. Now Alice can send her sensitive document again. She takes the document and encrypts it with Bob's public key. She then sends the file to Bob, who uses his private key to unlock the document and read it. Because they use asymmetric encryption, only Bob is able to decrypt the message. Not even Alice can decrypt it because she doesn't have Bob's private key.
Mm.
The strength and security of the asymmetric encryption now relies on Alice and Bob to keep their private keys well protected. If an attacker steals Alice's private key, it can be used to decrypt all messages that are intended for Alice. However, the attacker cannot decrypt messages that were sent by Alice because that requires Bob's private key. Asymmetric encryption is used in a lot of places where security really matters. You might not be aware of it, but every time you visit a secure website via HTTPS, you're actually using asymmetric encryption. It's also being used to securely send emails with the PGP protocol. And one last example, Bitcoin also uses asymmetric encryption to make sure that only the owner of a money wallet can withdraw or transfer money from it. So now you know how asymmetric encryption works and what the differences are between asymmetric and symmetric encryption. If you like this video, consider
Okay,
supporting
you
me
can
by
pause here.
sharing it
Yeah.
and
Alright.
subscribing.
Okay. So during the actual assessment or evaluation part of this, you're not going to be able to look at your sketch notes.
Okay.
So if you want to take around like 30, 40 seconds to study your notes right now,
Okay.
give that a shot.
All right, I'm doing that now.
Great.
You tell me when to stop, and then I'll close my book.
Okay. Yeah, that'll be good.
Close.
Awesome. So here's the next video. I just sent it in chat.
Okay.
So this is a YouTube short. It's a little confusing. When you open the link, it might like scroll down automatically. It's going to be the top one that you open, that shows up when you open the link.
Okay.
See? Now, this video is going to be a little more complicated to build in your mind as a 3D model than the last video.
Okay.
This video is purely 2D, and it shows like some things that you're going to have a hard time picturing verbatim. For instance, it shows a grid of like 100 by like 10 people, like 1,000-person little grid, which is obviously hard to imagine. But I'm going to walk you through how to actually visualize these things. Now, the next step before you go on to this video is choose a place also in the town you live, but very, very far away from where you placed the tumbler lock. So I'm talking like a mile away. As long as you're able to walk from, as in mentally you could, you know the route from the lock to this new location. Let me know when you have it.
I've got a spot.
Great. So you can open up this new video and share your screen.
All right, so I've got that open. I think I need to come back to our discussion to share.
Mm-hmm.
Then I get to choose medical test paradox, I think is the one we want.
Yeah. Yep.
Let's share that.
Great.
All right.
Okay.
Here.
So for this, do you see how it shows a ton of little white dots?
Yeah.
So obviously, you can't render that, right? Instead, what I'd render is just kind of a blob, not a blob, but like a lot, almost like ... in my head. When you see that many, and you can also represent it with proportions. So if it shows like 120 out of 1,000, you don't have to literally represent 120 out of 1,000. You can guess at around how 12% of this area is. Now also, the previous video you watched, the tumbler lock video, wasn't so conceptual. It was really a physical mechanism. With this video, you're going to be representing something that is a lot more conceptual. Luckily, though, That is something the Atlas excels at. The special case you saw of the tumbler lock, it can totally do. It's kind of like a happy accident that it's perfect for rendering 3D models. But typically how people use it is to represent deeply abstract and conceptual ideas. Also, this video is very short. It might help for you to just watch it one time through, and then we'll watch it again, and I'll tell you when to pause and build things.
So an interesting question before we begin is,
Yeah.
how many of these Atlas points can you assign to a location? So you're telling me to assign this to a separate location that's walkable. Is there a maximum number of items you can assign to a location? And that was my guess by going to another place, that maybe this is just a way to demonstrate a different place. Maybe that's not a limitation.
Sure. When I ask you to show it very, very far away, the point of this is to show it's not like the Mind Palace where you're going to have to walk. In my head, I have in my hometown like 4,500 of these.
Okay, got it.
In a convenience store down the street, I have 70, just packed really, really tight because I have really good visuals of that. You could totally build this video right next to the tumbler lock. But this is to show that even if in your head, these videos are represented miles apart, you can still snap between them totally fine.
This would be the compare and contrast to the Memory Palace idea where you're in one location with, I don't know, mailboxes or slots or something like that. Okay, got it.
Yeah.
All right, I'm going to play the video now, and then we'll stop, and then I can play it again when you're ready for me.
Yeah,
all right, here we go.
Great.
Some of you may have heard this paradoxical fact about medical tests. It's very commonly used to introduce the topic of Bayes' rule in probability, and suppose that 1% of them have breast cancer. And let's say they all undergo a certain breast cancer screening, and that 9 of those with cancer correctly get positive results, and there's 1 false negative. And then suppose that among the remainder without cancer, 89 get false positives, and 901 correctly get negative results. So if all you know about a woman is that she does the screening and she gets a positive result, the probability that she's in the cancer group, given the test result, is 9 divided by 9 plus 89, which is approximately 1 in 11. So the paradox here is that, in one sense, the test is over 90% accurate. It gives correct results to over 90% of the patients who take it. And yet, if you learn that someone gets a positive result without any added information, there's actually only a 1 in 11 chance that that particular result is accurate.
Okay. So people typically
Picture
find that
1,000
video
women and suppose that 1% of them have breast cancer.
How do you pause?
And let's say they all undergo a certain breast cancer. Some of you may have heard this paradox.
No.
I don't know why it keeps jumping to that, but
Yeah. I think his short is like linked to the longer video.
yeah. I think so.
Yeah.
And if I go back, it'll start playing, so I'm going to stop.
Okay.
Wait.
I can actually, you've seen it, so we can just talk here and then you'll be ready to go.
Okay.
Typically people find that video super complicated, a really hard conceptual thing to understand. I'm actually gonna ask you to steer for implementing this video. So anything that the author makes, you build as a 3D model. Again, when the author shows you like 1,000 people, just render it as like an area. And then something that's a really nice trick is this video is actually presented already in like the perfect form for using the Atlas, meaning it's like a picture and someone describing how this picture works.
He's doing the dual coding for you in a way.
Exactly, he's doing the dual coding. So actually, you kind of jumped into how I encode super fast. I literally look at the screen, build in real time, super fast. Look over here, and then I'm listening to the author's voice, and then I actually repeat what the author says back in my head, but I'm focusing on my visuals. So when I found out this worked, I was dumbfounded. Before that, I was watching a little bit, I'd pause, I'd build, I'd pretty much do what you did in the first video. Realizing that you can just use this in real time is way better. So you can actually experience what it's like to repeat my words back with the voice in your head. So right now, as I'm speaking, try to repeat like what I'm saying, but using the voice in your head and see if it makes sense. And like, you seem to be able to follow what I'm saying. So I can get into a little bit of the video just as you're performing this task. Okay, I don't know what to say. But were you trying it a little bit? And was it like, did you get the vibe?
Yeah, I think so. So what I'm going to do is, I think if I'm to describe before I do so,
Yeah.
I think what you were saying is you realize that he's showing an image. We can represent it as rough approximations or percentages. And that as he's describing what he's talking about, that I could actually repeat what he's saying. I'm guessing I can repeat in my own mind.
Yeah, totally. Yeah.
Right? He's saying it, and you're sort of, in a way, you're dual coding on top of his video.
Yeah.
Is there another step where we pause the video and then rebuild the information and repeat it again the second time as kind of a verification?
Yeah, there is actually not.
Okay.
In my demos, and they were somewhat annoying to make, but I essentially did the exact task you're doing now, which is watch lectures, build in real time, and then do the reasoning synthesis task. I only could watch them once, no pausing. One of them I paused because it was completely out of my depth. It was on like a mathematical identity of greens function, and involving like the Dirac delta function and functional operators. I don't know what any of that is, and so I had to pause. But yeah, for all the other videos, there's 1.25x speed, pretty much no pausing the whole time.
Okay.
And with like excellent, like ridiculous retention.
Well, and of course, you're practiced at it, so I think you probably are up to speed.
Yeah, not everybody.
You have to build up to that point. Yeah,
definitely. Yeah. Okay, so you can go back to the short video, and you can give this a shot. And it's totally fine if you have to do it even twice, or if you have to pause. That's entirely fine. Again, watching at 1.25x speed, doing all this in real time is something that might come with practice. If you can do it first time, that's great. Some people can. Sometimes it takes a little more practice.
Yep, I'm at noob level, like my son would say in Minecraft. So working my way. Okay, here we go. I'm gonna go back, and I think that should reload the original video.
Great.
Picture 1,000 women, and suppose that 1% of them have breast cancer. And let's say they all undergo a certain breast cancer screening, and that 9 of those with cancer correctly get positive results, and there's 1 false negative. And then suppose that among the remainder without cancer, 89 get false positives, and 901 correctly get negative results. So if all you know about a woman is that she does the screening and she gets a positive result, the probability that she's in the cancer group, given the test result, is 9 divided by 9 plus 89, which is approximately 1 in 11. So the paradox here is that, in one sense, the test is over 90% accurate. It gives correct results to over 90% of the patients who take it. And yet, if you learn that someone gets a positive result without any added information, there's actually only a 1 in 11 chance that that particular result is accurate.
I'll do it one more time.
Okay.
Picture 1,000 women, and suppose that 1% of them have breast cancer. And let's say they all undergo a certain breast cancer screening, and that 9 of those with cancer correctly get positive results, and there's 1 false negative. And then suppose that among the remainder without cancer, 89 get false positives, and 901 correctly get negative results. So if all you know about a woman is that she does the screening and she gets a positive result, the probability that she's in the cancer group, given the test result, is 9 divided by 9 plus 89, which is approximately 1 in 11. So the paradox here is that, in one sense, the test is over 90% accurate. It gives correct results to over 90% of the patients who take it. And yet, if you learn that someone gets a positive result without any added information, there's actually only a 1 in 11 chance that that particular result is accurate.
All right, I'm going to kill that just so it doesn't play again.
Yeah, sure.
I can't help but do some, as I'm doing this activity, just sort of imagining like the meaning of it, which the meaning I take away is tests are great, but it's only one point of data, and that you need other factors to kind of help deal with those, the false negative and the false positives in that example, right? Which is the test is both accurate and has problems if you only rely on it. And that would be
what you just did is going to help you in the later reasoning task.
Yeah. I hope.
Were you able to build the model and then do the voiceover?
Yeah, I was kind of like silently in my head repeating.
Yeah, perfect.
As he was saying it, I was repeating it in my head.
Yeah. And when you were repeating it in your head, you were looking at your visuals, correct?
Yeah.
Great. Okay. And how was it trying to do that in real time?
It was weird. It was
Yeah.
weird, I have to admit.
You can see me on the demos. I'm going full Doctor Strange. Like I actually look like this. So yeah.
Right.
Yeah. That is actually probably only the big downside of the technique. There's a couple like small annoying things, but this is actually a pretty annoying one, which is if you're using it intensively, your eyes dart around, and it's very tempting to have your head like dart to where you're looking, especially if you're thinking fast, which is which is funny. But if you're using it for like regular purposes, not like watching 7 lectures,
You just
1.25x speed.
make sure you do it in private, I guess, is the answer, right?
Yeah. And the nice thing is you can use it, the voice in your head. If you had to talk out loud, it would be like, that seems cool. But okay. So here is the last video you're going to watch.
Okay.
You're going to play this on 0.75x speed. The reason you're going to play this on 0.75x speed is the author talks at 1.5x speed.
Okay. So he's a fast talker.
Yeah. Yeah. So this is actually super, super similar in terms of the skills you're going to need to encode it between the Tumblr lock and the medical test paradox video. It's just visuals and analogies and all that stuff that it seems like you're used to by now.
Okay.
This actually has one thing that's a little different, which is it has multiple visuals within the same video. The previous videos were kind of like one thing you were building on. All you have to do is for this video where it shows you like an image, just put those all right next to each other. And also to show that a limitation of the technique is not you can only put like one thing in one part of your town. You can store this video in somewhere like super, super close to the place where you stored the Tumblr lock video. So even like in the same house. Yeah.
You get a different seat at the table or something like that.
There you go. Yeah.
All right. So I'm going to open this up. I'm going to pause it before it takes off. All right. I'm going to roll it back to the beginning because I have to come back here and I think I need to share that screen. So let me get this one. This would be, does pressure keep? Okay, there we go.
Yeah.
So you should be seeing it. There we go.
Yeah, perfect. And this is at 0.75x speed. Just to make just a reminder.
And do I need to set that or is it already preset to that?
You need to set it. Yeah.
Okay. So I think it's under settings, playback speed.
Perfect. Yep.
7.5.
Yeah.
Okay.
And even with this, he does talk kind of fast. So it's totally fine if you want to pause. Or if you want to try to build it in real time, it's actually easier, like way easier for the following cognitive reason. What you're doing when you're pausing is essentially waiting until your working memory buffer is entirely full. Then you pause and you try to write your working memory into the atlas.
I see.
Which takes executive function, like managing this transition process takes executive function. And then you unpause and do the whole process. So essentially the whole vibe is like fill my working memory buffer till failure and then dump it strenuously. When you do it in real time, it almost works in like an inductive hypothesis, like almost like a slinky rolling down a hill, like it's just going to keep going, kind of like this. It asks the question, have you understood everything up until this point? And it's in your atlas. And if you go, yes, I have, then it goes, do you understand the next sentence that this guy says, given that you've understood everything in the video before? And you go, yes, I understood it. That immediately gets written onto your atlas. And then comes the question before. Did you understand everything that you've watched in the video? And we just said yes. This holds true because in the very beginning of the video, I guess vacuously, by definition, you understood everything in the video so far because there was nothing in the video. So that's kind of like the theoretical reason for why watching it in real time is not only like way more efficient, but also easier.
I see. So that would be ideally like someone like you who's practiced this technique would never pause. You would just so the question I would have is like, are you reaching like limit your placing and then resetting and coming back pretty quickly? I'm assuming. That was the image I had. What you're talking about is you would load up your buffer, you would place it, reset, and then come back and start again. Load up, place, reset. Is that what you're doing?
So what I used to do was I'd literally watch part of the video, and then I'd wait till I understood something, then look to the side, bring up the visual of my atlas, build what I remember seeing, and then do the voiceover. Then close my atlas, watch the video. Now
so
what I do,
the video then. Okay. Originally.
Yeah. Now I just I watch the video, wait until a visual shows up. As soon as the visual shows up, before I even know what it represents, I build it.
I see.
Then out of the corner of my eye, I watch to see if the video visual is changing. If the video visual is not changing, then I know that the author is describing what the visual they just showed me and then I just built means. And so I'm talking over it. And then I can see if the colors change. And then I just go like that and then build.
Do you ever have a problem where what they're saying and what you're thinking crash into each other? And you get
then I pause. Yeah.
Okay. Yeah.
Like in the greens function video on the 16 item demo, I had to pause because I'd be narrating and it'd be like, okay, so take this general operator and modify the greens function with a direct delta. I'd be like, I don't know what that means. I have to pause. But yeah, as long as you're watching things that are not like within your ability to comprehend, but like things you have background knowledge for, you're good. To give you a sense of how much better I can do with this technique, if I'm watching anything above a Kyrgyzok video, if you know that YouTube channel, do you know Kyrgyzok?
No, I don't know that.
Do you know Veritasium?
I don't know that either.
It's actually, you see the Bayesian trap, that guy? Or okay, better example. Yeah. Pretty much any of the videos you just watched, if I watch those without this technique, I can't understand them. Like I don't remember any of them. That part of my brain is so bad where I have to like remember things that I have learned. With the technique though, I can like one shot 1.25x speed, like super complicated stuff. I wish I had it my whole life. I didn't. So I forgot most of everything I learned before. I guess
so like Ted Jackman is human is basically what you're saying.
More than
or not a robot. With a tape recorder in your brain. Wow.
Okay. Yeah, you can. So if you have your location, you can go ahead and start this.
All right. So I'm moving to another spot on the same table. I'm sitting against the wall or against the window. I apologize. And I'm going to begin.
Does pressure keep the deep ocean from freezing? No, but you were probably hoping for a more in-depth answer, so let's take a deep dive to the bottom of the Mariana Trench, the deepest part of the ocean. Down here, there's 11 kilometers of water pressing down on you from above, and the weight of all that water generates around 1,000 times atmospheric pressure. And pressure can melt ice. Like, you only need 500 times atmospheric pressure to melt ice down to -4 degrees Celsius. And if you have 1,000 times atmospheric pressure, like at the bottom of the Mariana Trench, then you'll melt ice down to around -9 Celsius. But that's for fresh water.
Okay, I'm gonna pause that for a minute since I'm new to this technique.
Yeah, and this is also super unclear.
Yeah, I'm sort of halfway into it, and probably maybe a better technique could be to watch the whole thing and then come back and do the pausing, so you get sort of the breadth of the whole thing. I don't know. What do you recommend there?
So you would think that would be a good strategy, right?
Mm-hmm.
And I actually thought, in discovering this technique and all this is an exact thought I had, which is this is too complicated. I can't build this in my head. And I'd experienced the following. Whenever I would build it in my head, it wouldn't be complicated. And whenever I wouldn't build it in my head, it would be complicated. And so I'd assume it was too complicated to build in my head. And then one day I was watching a video that was too complicated to build in my head. And then I built it in my head.
There you go.
And it was no longer complicated. So essentially the fundamental question this asks is like, if you understood everything up until this point in like your long-term memory, like you deeply knew everything up until this very thing the author says to your bones, could you feasibly understand this literal next idea? If you think you are capable of doing that, then you can build it in your head. Again, this fails if I try to teach you, like a Nobel Prize winning like quantum mechanics that's currently being developed. Like you would not be able to, even if you understood everything before, you'd be like, I can't understand that. So yeah, go ahead and try to build this in your head, and you can actually see if I'm fibbing. Yeah, build it in your head, and then do the voiceover, and hopefully you'll notice, I guess I can understand it.
All right. So I'm the topic here is does water freeze at high pressure, low parts of the ocean? He introduces the concept and then shows a Marianas Trench, a deep trench. At the very bottom, he talks about the pressure that would be happening, which is 1,000 atmospheres at that level. And then he starts the comparison by talking about at 500 atmospheres, water or ice can melt at -4, but at 1,000 atmospheres, it would be -9% Celsius. I guess that's clear Celsius. And now I'm going to continue again.
Great. And now that you've done the visual and the voiceover, does it feel like more intuitive and clear?
Yeah, it feels like a whole picture.
Yeah.
It's like it's layered. I'll call it almost like layered information.
Sure.
Rather than a static, even though it's two-dimensional image.
Yeah.
It almost feels like the voiceover is another track. I think about like so when I edit movies in like iMovie or something like that, you have the video component, and then you have the audio component, and then you have fade-ins and outs and overlays and things. I think of it that way, almost like layered. It would be the way I would visualize it for you in description.
Yeah. Absolutely. Sometime because the discussion would be about like what's actually going on in terms of this other track is somewhat lengthy and complicated. If you're ever interested after the recording or some other time, I'd love to share the like science of that weird feeling you're getting of other track. Because luckily people have studied it and stuff. So yeah.
Probably the last thing I'll close my eyes and describe that all the stuff that he's described to this point talks about fresh water. So my assumption here is that there are different properties with salt water, which we'll find out.
For salty seawater, everything more or less gets shifted colder. On the ocean's surface, salt water doesn't freeze until around 2 degrees Celsius below zero. At 500 times atmospheric pressure, salt water doesn't freeze until around 6 degrees Celsius below zero. And at the bottom of the Mariana Trench, salt water wouldn't freeze until around 11 degrees below zero. But for various reasons related to circulation and salinity and convection and the fact salt water freezes into freshwater ice, for complicated reasons, deep ocean water is often around 0 to 4 degrees Celsius, and doesn't really get much colder than 2 below zero. These are temperatures at which the water would stay liquid from salt alone, even without the additional pressure. So while pressure could in principle keep the ocean from freezing, it doesn't really get a chance.
Okay. So I'm going to stop. I don't know how much of that I'm going to remember now.
So
talk a little bit about saltwater dynamics change. Everything gets colder. I thought it was interesting when he described that frozen water is actually freshwater ice. So does that change? My curiosity said the rule when you're on the sea is you don't drink salt water because it drives you crazy. Could you eat ice?
I think he said that the water on the ocean's surface was ice. Wait.
I think he said it freezes as freshwater ice. I thought. Should I go back and see?
Yeah, I forget.
I'm kind of curious.
Also, do you know how you watched and now you said I don't know how much of that I'll remember? You just used the part of your brain that is not the atlas. So you remember how I said when the pause thing, you want to fill up your working memory buffer until failure? You went past that point.
Okay.
You went after failure.
Okay.
Yeah.
No, I'm so
if you want
curious
to rewind, there you go. Yeah.
Surface, salt water doesn't freeze until around 2 degrees Celsius below zero. At 500 times atmospheric pressure, salt water doesn't freeze until around 6 degrees Celsius below zero. And at the bottom of the Mariana Trench, salt water wouldn't freeze until around 11 degrees below zero. But for various reasons related to circulation and salinity and convection and the fact salt water freezes into freshwater ice.
See, that's interesting.
You're
if you
right.
Were on the ocean, that you would actually be able to eat ice on the ocean because it's fresh water. which and I think of that because I just read a book about Vikings, and I wonder if they knew that, like they knew not to drink ocean water. Maybe if they encountered ice, that it would be edible. I don't know. That makes me wonder why does that happen, but they're not going to touch on that here, obviously. Okay.
For complicated reasons, deep ocean water is often around 0 to 4 degrees Celsius, and doesn't really get much colder than 2 below zero. These are temperatures at which the water would stay liquid from salt alone, even without the additional pressure. So while pressure could in principle keep the ocean from freezing, it doesn't really get a chance. Alright, now is your chance to try out the new map.
Okay. So I'm going to go back and see if I can describe what I just saw. I might have messed myself up by asking all these questions out of curiosity, but so basically
the really nice thing is I'm guessing the part you actually like faithfully stored in your atlas is entirely clear, meaning it didn't fade. And I'm guessing the part that you didn't got interfered with by normal working, like, because you did something else. So this is something I encounter all the time. When I'm thinking I have to put something in my atlas, because it does not take interference. For instance, in the demo I did where I watched like the 7 22-minute lectures, I cannot do that like at all without the atlas. Like the last lecture I did on the evolution of rock, paper, scissors, shoot, I was fighting to stand up. No focus, except I remember it perfectly. But I have a terrible memory otherwise.
So basically what you're saying is you need to sort of lock into this method once you commit to the atlas method. You got to lock into it, finish it before you can ask questions. Focus, like you basically can't mix the two modes.
Yeah. So it's a little different actually. It's that you can mix them. It's just if you mix them, you will be getting some of perfect retention and some other of watching very, very complicated, fast video and not retaining it.
I see. So just a trade-off in effect.
So it's not like using the atlas makes typical learning any worse. It's instead that you are experiencing what it's like to have like perfect retention, and then you're intermixing terrible retention. And so it's kind of like an easy like error assumption to make is, oh well, I'm doing bad with this, so it must be that thing that's making me do bad. And instead it's just like nope, that's just how you are.
Yeah. Interesting. Okay. I saw that the video was longer and I expected more, so when it ended I realized it ended the first time, but I wasn't sure there was still more. And I understand why they do it, but now, would it make sense? So I don't know how well my atlas model got built. Should I start this again and do it again as a way to
it's only like a minute. Go ahead and start it, do it again. Make sure you build all the visuals and do the voiceover with everything this guy says. And then
because I don't know that I accurately built everything that I should have.
Gotcha. Yeah.
So I want to kind of do it again, and then I guess I need, then after I build the models, then describe what I'm seeing.
Great.
Does pressure keep the deep ocean from freezing? No, but you were probably hoping for a more in-depth answer, so let's take a deep dive to the bottom of the Mariana Trench, the deepest part of the ocean. Down here, there's 11 kilometers of water pressing down on you from above, and the weight of all that water generates around 1,000 times atmospheric pressure. And pressure can melt ice. Like, you only need 500 times atmospheric pressure to melt ice down to -4 degrees Celsius. And if you have 1,000 times atmospheric pressure, like at the bottom of the Mariana Trench, then you'll melt ice down to around -9 Celsius. But that
Ted, should I be describing my model as I go, or should I do it?
Yeah, you should.
Okay. All right, that's what I thought. So coming back to the image, the question was, does pressure melt frozen ocean water? And the answer is no, and he is describing how that works. He draws an image of the Marianas Trench, which if you were at the bottom of it and you were still somehow alive, the 11 meters of pressure would be about 1,000 atmospheres of pressure on you at that point. And then he goes into detail describing that normally water pressure does melt sea ice, but it melts it at, I need to go back and see that number, at 500 atmospheres, -4 Celsius. And at that pressure of 1,000 atmospheres, it's -9 Celsius. But then he goes on to say that it only holds true for freshwater and not seawater. And now he's going to describe the seawater.
Celsius. But that's for fresh water. For salty seawater, everything more or less gets shifted colder. On the ocean's surface, salt water doesn't freeze until around 2 degrees Celsius below zero. At 500 times atmospheric pressure, salt water doesn't freeze until around 6 degrees Celsius below zero. And at the bottom of the Mariana Trench, salt water wouldn't freeze until around 11 degrees below zero.
So on the saltwater case, we've got an image of saltwater changes. Here we see that saltwater freezes at -2 centigrade, so it's quite a bit colder. At 500 atmospheres, -6, and at 1,000 atmospheres, -11. So everything shifts colder for saltwater. Obviously, in what I see here, the salinity resists freezing a little bit better than freshwater.
But for various reasons related to circulation and salinity and convection and the fact saltwater freezes into freshwater ice.
And now I'm going to stop and describe this. He talks about the reason why it involves salinity of the water, which I imagine must have variability. Convection, which is flow of water, warm and cold currents. And then he throws in an interesting little tidbit that when salt water freezes, it freezes as freshwater ice, which I thought was interesting because it made me wonder if I was, in the Titanic and I was desperately thirsty, I apparently could eat ice and not go crazy from drinking salt water. All right, now I'll continue.
For complicated reasons, deep ocean water is often around 0 to 4 degrees Celsius, and doesn't really get much colder than 2 below zero. These are temperatures at which the water would stay liquid from salt alone, even without the additional pressure. So while pressure could in principle keep the ocean from freezing, it doesn't really get a chance.
So in the final images, he talks about the fact that salt water, when it's in the ocean, only really gets to not even to a negative temperature, so it always stays above freezing even at these low locations because of all those elements, and nothing to do with pressure, because the other elements are actually keeping it from freezing before pressure even has a chance to have an impact.
You did it.
All right. I don't know. I kind of, it was a little bit interpretive.
That's good.
Maybe that's okay though,
Yeah.
I think it's got to be in your own words, right?
It entirely. And these videos are, like a lot of videos are super terrible on working memory and retention because everything in education says you got to keep the visuals up on the board. Like every visual you need to keep on the board. Videos do not do that. By definition, there is a small board. And so typically when people watch videos like this, they'll see it and then go, I understand that, and then they'll change the visual and they go, oh, that's gone. Hopefully now it is not gone for you. Okay. I
bring up an interesting question before you proceed, and that is
entirely.
If it was important for me to remember the exact centigrade numbers, negative and positive, would it make sense to go back through with my model and then assign exact temperatures to it? Let's say I'm going to be tested on those, right? So like I have conceptually, I understand, and I have a general sense. I don't work in centigrade, so that's one level of abstraction I'd have to think about. But I get the concept that down to 0 degrees is in centigrade is not freezing. At 0 it freezes, right? And so like if I wanted to remember those exact numbers, maybe I would do another pass and assign the exact numbers to my model.
So there's actually a strategy you can use for this, which I had to figure out painstakingly. And it is generally asking the question, how do you represent symbolic math? And unfortunately, unless you have a far, far better visual retention of like pixel-wise information than me, meaning like you can visualize like a very long math equation and remember it pixel perfect. You can't do that, as in you can't represent those symbols. However, there is actually something you can do, which is represent everything geometrically. If I wanted to represent the equation x cubed minus 3, I would actually do a cube, like a cube that's blue, and then 3 little red things, like red meaning minus, as in
Three portions.
Yeah, 3 little red cubes, like yeah, in the blue, and that perfectly, like geometrically and analogically represents the idea x cubed minus 3. So to answer your actual question, how to represent -2, -6? This is, I don't know why this works, but it works. You do little guys of different heights. You know how when you look at somebody on the street and somebody says, that guy like 5'9" or 5'11", you're like, he's 5'8". Like, I don't know, for some reason, we have really, really good circuits in our heads for estimating precisely how tall a person is. And that seems to carry over to your visuals. So yeah, typically I can remember, like actually I did this in the demo, the 7-item demo video. The Bluetooth video required that I memorize a bunch of frequency ranges. And so I had to memorize like 2.4 gigahertz, just like random numbers. And in that case, I saw a guy who was 246 feet tall. In singular value decomposition a lot, I have to memorize matrices. But that didn't make sense. I was watching a video on singular value decomposition for my computer science masters, and I had to memorize a bunch of matrices, like, grids, with specific numbers, which is awful. Terrible thing to memorize. What I had to do is I put little guys in all the boxes, and it worked fine. I still remember all the numbers.
So you're sort of piggybacking off of this capability we have to estimate people's heights. Yeah. I can tell you that I have an interesting story from my dad. So he used to work at a wire company, and his sensory capabilities were really good. So he could feel wire and tell you what the gauge was. So he had built some kind of a memory of feeling. Yeah. And you wouldn't have to look at the casing where it would list it. He could close his eyes and feel it 910 gauge, whatever, and he could feel it. That was really fascinating to me.
Yeah. Huh. That is super, super cool.
So I don't know if maybe there's some, a touch component that could also be beneficial for if you're memorizing.
There is definitely, but actually structurally similar to the video you just watched. It's not necessary. It's covered by the other features. If I really, really, really need to memorize something, like you say, like, oh my gosh, like, you'll save the world if you memorize this one number.
If you get one decimal off, you're gonna screw it up.
Yeah. Like I would incorporate touch. I would animate it. There's a lot of things you can do to like really remember it. Typically though, it's just not necessary. You'll remember almost everything. The practitioners of this technique too, like Rohan Reddy, who's is entering his med school. He says like, yeah, I can tell you everything I've learned over the past 3 weeks in detail. Like just everything, which is not something typical. So yeah, you'll just remember this stuff. However, without further ado, you can look in the chat. Actually, do you have any more questions, or do you want to do the reasoning?
I think that's it. I keep interrupting flow here, but
yeah. Okay, so you can click on that link. This goes to the website, and it has the 35 common topics that test the difficulty of the MSST. The MSST is the multi-system synthesis task, which is what you're about to do. All right. Here's the goal of the multi-system synthesis task. You want to do almost New York Times connections. Do you know that game?
No, I don't think I played that before.
Okay, gotcha. I probably shouldn't have used it anyway because people watching might not know it either. Okay, so you're going to have 3 concepts. One of them is asymmetric encryption. The other 2 are items from this list. There are 35 of these. You can choose any 2, the ones that you're most comfortable with. You're going to take those 3 items and you're going to try to find deep structural analogies and connections between all 3 of those. without looking at any notes, completely in your head.
Okay.
This is a task that humans find difficult.
All right, and I did the asymmetric model with my Sketchnote. So does that? And so we're going to compare. So do you want me to take these other two, and am I doing the Atlas method with these three now?
You are not.
Okay.
This is the control. With you're not allowed to look at your sketch notes. You're going to choose two of these concepts. You're going to choose two of these concepts. And actually, would you be able to share your screen and show the list?
Yeah, I wanted to wait until you were ready for that.
Oh, perfect. Yeah. Appreciate it.
I'd like to look at people as they're talking if I can.
True. Respectable trait.
Yeah.
Okay. So you can choose any two of these that you find really you really feel like you know well.
What if I don't know any well?
Yeah, I can give you substitutes.
Simpler ones. Yeah, what if I'm not smart enough to know all these things?
I do have other ones.
No, I'm scanning through these. The World War II one looks interesting. That would be one I'm interested in.
Yeah, let's go ahead and choose that one. So you need one more.
Awareness. A lot of these technical ones, I'm not super.
Yeah.
Okay, I got to the bottom. All right. Maybe I would choose world religions and their historical impacts.
Sure, that's great.
I would choose World War II.
Okay.
Positive events and outcomes.
Yeah. Okay. So you have world religions and their historical impacts, World War II, and asymmetric encryption.
Right.
Now, go ahead and close this list so you're not looking at any visual aid or anything. You are entirely allowed to visualize during this task. The only thing you're not allowed to do is secretly use the Atlas.
Okay. All right.
Do you know probably what I mean by like deep structural analogies? Is that something you're
put a definition on that to make sure I'm following.
Yeah. Here's like a bad analogy between a bad answer between World War II and religions. You would say that in Nazi Germany, religion played a really big part, and that is religion. That would be a really bad answer. I'll give you a good answer between two of them. We'll take I'll just find two of these. These are electromagnetic spectrum and light interactions, let's say, and the water cycle and its global impact. So you would say there's oscillation in both of these. The water cycle goes water to clouds to ocean to water. And in light, you have the interaction between the electric and magnetic fields that propagate through time. So you have this structure of interactions allowing a system to propagate through time. That is an example of a very good connection. And not a very, very good connection. That's like he did the task. So you want to find connections like that. So give it a shot across these three.
All right, let's see. Well, I think you want me to talk out loud as I'm doing this association. So I guess I would start with the thing I'm most familiar with, since I just did a video on it a short while ago, which is this asymmetric key generation. And I find it interesting that each person in the group has a public and private key, and that when they're mixed together, that produces a third thing, which gives the security, and that even if someone were to crack the first person's key, that would not allow them to crack the second. So that's an interesting separation of powers or separation of controls. I think about World War II, and I think I've just been watching World War II videos on YouTube lately for some strange reason. I think it was kind of interesting that that for a while the U.S. particularly wanted to stay out of the conflict, and at the same time where there were people that were involved, some people in flying planes in China. So there was sort of like the original like a symmetric connection where it was one person, one group going over and leaving the U.S. and flying these planes in China against Japan, or maybe the Merchant Marine were providing supplies to the UK, obviously getting paid for it. So there was like components of it that were happening, but it was not systemic. And I think about once 1941 happened, the U.S. was sort of forced into now joining with the Allied powers. So in a sense, that's a little bit like these public and private keys. I know there's a component as well with encryption related to the Nazis and the way they used encryption. That's an interesting, probably side little piece that feels like maybe a potential connection. I don't know if that's a good connection or a bad connection, but it feels like the combination of all these Allied powers when the U.S. entered, it changed the dynamics for the shift in how the war went. Because I think to that point, Germany was pretty dominant. And when the U.S. came into the conflict, it changed the dynamics a lot. Specifically, I probably could get into details, but I can't think of anything at the moment. And then I need to also assign like how would religion fit into this as well. And I would think, the multiplayers, I think about it like multiplayers maybe. So in asymmetric encryption, there's multiplayers, right? You need two people and they have a public and private key. In World War II, there were multiplayers. There was a small group of Allied powers, and then it was the U.S. added to it. In religion, I guess you can go back in history, but if we want to start with Judaism, there begins Judaism. From it comes Islam, and then from Judaism at a later time comes Christianity. So there's this, if we limit it to only those three religions, which there's plenty more, that it's this combination of the three changes the dynamics again. So there's sort of this connection between dynamics and players. Where
okay.
In the first one,
you here.
Single player. Okay, go ahead.
Okay. One, great, nice work. You stuck with it. And two, was that difficult?
It was, yeah. I mean, I had to really think about it. I was not using the Atlas method. I was just reasoning, my normal reasoning, like how would I reason through this?
Mm-hmm.
And a lot of it is for me is talking.
Yeah.
So speaking is a part of it. So yeah.
So let me know if this cold read is like accurate to what was happening in your brain. You would pull up the like concept of one of the things.
Mm-hmm.
It would not show up as a full thing at once. It wouldn't show up as like a full concept. It would instead show up as like a vague sense. A vague sense. Then you had to talk out loud to almost elucidate the other properties. After you'd talked out loud to elucidate more of its properties, it was then more full. Then you would analyze that thing for a pattern. You would then get that pattern in working memory. At this point, you would go, okay, got a pattern. Then you would have to almost manually transition your working memory over to the other example, which in your case, the second one was World War II. And now you're holding this pattern in working memory, which is what you figured out from the asymmetric encryption. And as you are holding this asymmetric encryption pattern in working memory, you now have to repeat this process almost again, where you have to talk about World War II. You have to change it from this like general vague sense to actual details. Then only after like getting a lot of information and details about World War II, can you actually find this pattern in World War II. Then you had to repeat this again. At this point, your brain's getting somewhat full. You had to repeat this again with religion. And then you went, okay, this pattern was present across all three. And when you transition to religion again, the important part is you had to like manually and with executive function transition your working memory over there. Is this somewhat accurate?
I think so. Probably the only thing I would say is because I did a sketch note of the first concept, it didn't take very long to load into memory because that image was in a way like the Atlas, but not spatial. So I can close my eyes now and see roughly the drawing and the concept is tied to it. So in some ways, you're sort of doing the Atlas on paper. It's just not three-dimensional. I can't turn it and hold it. I suppose it would be interesting to talk to you about, could I take old sketch notes, bring them into working memory, and make them into atlases, right? That's interesting.
You definitely could.
That would be my only modification, is that the first one loaded pretty quick. The other two and then the reasoning was accurate.
Okay, great. Okay, so now you're going to try the MSSD with the 3 novel videos, but in your atlas.
Okay.
And you're going to have an advantage in your atlas, which is the following. You only need to think about one of these items at a time. So you could start with the Tumblr log.
Okay.
You are going to start, like, while visually focusing on the Tumblr log, you are going to start analyzing the Tumblr log for like deep patterns and structure. Now, you will not have to manually transition your working memory over to the medical test paradox or the ocean freezing video at all. Instead, what will happen is as soon as you notice a structure or a pattern that in the Tumblr log that is present in either the medical test paradox video or the ocean video, your visual attention will just snap there automatically. It won't be that you think, oh my, there's a connection, and then you move over there. The connection is found for you.
To you.
It's done by your visual system. So one thing you can do also, if nothing comes when you analyze the first object, is then you manually transition to the second object. You start analyzing it. What could happen is if you start analyzing the first item and you didn't actually have that deep of an encoding for the second two, then you might not jump to anything because you don't understand them as well. But you can analyze one, analyze that, and then by the third one, you'll definitely snap to something. So yeah, give it a shot. You can start with any of the 3. And just start analyzing it for structure and let me know when and then when you snap, say the connection, and let me know that you found a snap.
Like document it. And so what I'm understanding is if the first one, let's say, doesn't automatically snap the thing, maybe going to the second atlas point would actually be a better connection for the other that you want to think about.
Mm-hmm.
Okay. All right. So I'll close my eyes since I did that when I generated this. I'm going to start with the Tumblr and sort of I'm reimagining myself at my kitchen table. I've got the Tumblr floating above it. It's reflecting on the table because the table's shining, so I can see it. I can see the front on view, and then I can turn it with my hand and I can see this. I can slice it away and see inside and see the tumblers working and master control. I don't have anything that's snapping immediately regarding the medical thing yet. I don't know if it's supposed to or not. Maybe
sure.
I did
the atlas, this is one of the tough parts of the atlas and why it's kind of really important to be on a video call. It sounds like what you were doing is describing what you saw, meaning like how the mechanism works. Your goal is instead to find like deep patterns and structures. Wait, okay, I'll see there. You won't snap to anything if you're just describing what you see. If you said something like the following, if you said, okay, so you have a large number of objects that are independently acting and need to all be satisfied. I don't know if you would snap to anything, but if you said something like that, you might snap to something.
So you're talking more conceptually in that case.
Yeah. Yep. Conceptually, like abstract patterns. Yeah.
All right. Maybe I'll use is that exact thing and see if something comes up.
Yeah.
All right. So I'm imagining the first atlas point sitting at my kitchen table, and I see that there's many working parts that are working together. And when something aligns properly, there's a connection. I think I'm kind of snapping. I'm feeling like there's a snap maybe happening around the proportions of the counting related to the medical example with the false positives and false negatives that in a way the snap that I'm feeling is by sliding the key in it only unlocks the first level, and that for the full turn, I think what the concept in the medical thing was that might, in effect, that's like putting the key in and it fits. But like to turn the key, you need more information, which in a sense would be like the tumblers lining up and allowing it to move past the locking point for that. And And I'm just going to just kind of sit with it and see if there's any connection with the ocean water temperatures. In some ways, I'm getting the sense too that there's like a blocking mechanism, because with seawater, there's other components that don't ever come into play because other elements are preventing. So, and the connection between all these three is there's a little bit of a blocking happening. In the first one, it's not having the right key. The second one is having only one data point, and the last one is the convection and other stuff happening are preventing the freezing. I don't know if that does that. I'm just kind of rambling here at this point.
That was great. So what did that feel like?
I don't know. I kind of felt like maybe I was worried that I was trying too hard to make it work, but
sure, yeah.
there seemed to be like it took a few, because I'm obviously this is the first time I've ever done this.
Yeah.
But it seemed to me like after a little bit of like holding these three ideas together, like kind of together, it seemed to me like the commonality between them all felt like they all had a lock component to them. But then if you, in a different way of describing, which, the one lock was the conditions prevent freezing. In the medical thing, the single point of data is a lock in that it would be dangerous to use that as your only point of data in a very complex cancer diagnosis. And then in the key part, there was a lock that prevents you from turning it unless you have the exact match of the keyway and all the components lining up properly. Even if it's really close, it's still something is going to be misaligned and it'll lock. So locking seemed to be the connection. I don't know.
Yeah, that was excellent. So that analogy was also like really, really good. In terms of how well that scores. You used the concept of blocking and locking in like extremely far-ranging domains. How did that feel, reasoning about three things, compared to how it felt without the atlas?
Well, as a visual person, having some kind of a reference point is really helpful. In the first one, like I said, because I did the sketch note, I could bring that into memory, but the other two were totally off topic, right? Even though I'd watched one or two videos that maybe assisted me a little bit, but I hadn't watched any videos about religion, so I didn't get any help there. In the case of having these visualized atlas points, felt like there was a lot, like it loaded quicker. I don't know if that's a way to describe it. Like I felt like the stuff was a little more available to me, but I'm pretty sure that I'm a noob at this, so I think with practice it would probably improve. So, but it felt different.
Okay. So I have a couple more questions, which is when you said it felt like it was more available, when you snapped one of the icons, did it feel like as soon as you landed on it, you almost got the entire idea of it like in your working memory at once?
Yeah, I would say it felt like the whole thing was there.
Yeah.
I think it's fascinating too, because the second one you told me to be about a mile away. That was at my mom's condo, sitting at her kitchen table. I didn't tell you that, but so it's interesting that even that distance seemed to be a limitation. Like I didn't even think about the distance. It just, the idea was there.
Okay. And then with the snapping, was it kind of as I described, where just like when you noticed a pattern about one, you just kind of snapped to another one? And then the idea of this new icon entered your working memory, and it wasn't like almost like it was spelled out for you, right? It wasn't like that. Did it feel almost like the pattern you had from the first icon, it was still in working memory, completely unchanged when you snapped, but when you snapped, the meaning of the second icon entered your working memory, and now it kind of like blended, like almost immediately, like paint. And you felt this weird working memory state of like some new concept, and then you spoke, and as you spoke, you felt like what you were saying was accurate to the working memory state that was blended. Is that accurate?
Yeah, I think so. And I think what's interesting is, so I sort of set my baseline as sitting at my kitchen table, and two of the three were at my kitchen table, but at different positions. One was sitting at the end, one was sitting at a side facing the other direction. And as I was sitting looking at the lock and started thinking about the medical one, it's almost as if I didn't snap to the location came to me. That's the way I imagined it. Like it actually transported that image and put it on the table in between the two. So it's like I was like moving back and forth between these positions, and in between the two positions was the far away thing that got brought to me.
Yeah.
Rather than me jumping back and forth, like I had actually kind of brought it all together, and I was imagining them as a unit. I don't know if that's correct or not, but
that's what it felt like. Most people don't experience it like that. However, you got results.
Yeah.
So, so that is quite cool. So I can tell you really quickly what's going on in your brain, and why what you did is literally the smallest possible thing you could do. Your brain, the place in your mind, where this like atlas is stored, right? So the town you live in, this is represented, let's say, as one big network. Every single object in your entire hometown is represented as a little idea. Even like the little handle on your bathroom sink. Like if you can snap to it, there's a part of your brain that's a little circuit that's like, I am the handle on the bathroom sink. What you did when you encoded these icons, these 3 videos in your atlas, is essentially build up a beautifully, wonderfully large little idea in your hometown, in this part of your brain that represents the hometown. And it doesn't represent it just based on like surface features, right? So the lock isn't just like metal, round. It represents it like in the same way you thought of it. Like it almost like writes the working memory state you had of when you were thinking about the lock onto this storage in your atlas. Okay. So in your atlas, you have these 3 icons. Now, what happens with this snapping effect is you'll be thinking something. For instance, you'll be analyzing one icon and a pattern will enter your mind, this beautiful structure. This memory state gets sent down to the part of your brain that stores the atlas. And here's the important part. It gets compared in parallel with every single object in your entire hometown at once, like this. Am I this complex pattern that Mike just found? Am I this complex pattern that Mike just found? That with literally every single object in your hometown. The one that wins, the one that is the most like the pattern you just found, snaps. And you perceive that in less than a second and passively as a snap. Now, the second thing is when you hit a visual, like when you actually snap to something, you might think this is something I've never felt before. It actually is. If I ask you to visualize a close family member, so bring up a picture of a close family member.
Okay, I've done that.
Do you know how when I ask you to do that, as soon as the image enters your mind, it's not like looking at a meme someone shows you. It's instead like, yeah, that's like my family member. The entire idea of my family member enters my work memory right away. Yeah. It's like that. Except with the atlas, your brain actually has a way easier time doing this task. Typically, your brain, when I say like, try to remember the meeting we had last week, your brain is doing a much harder task. It's asking, out of all possible visual contexts, what is the idea that matches this weird query the best? That's way harder than the atlas task, which is within this one space. What matches this query the best? And so why is this important? Well, you right now have 3 icons. I have 4,500. I experience the snapping the same as you. I experience no additional cognitive load.
So just scale then.
Yeah. So it's this wild hypothesis of, and this is actually one of the craziest thoughts I've had in like my life, was back in January, I was where you were, which was 3. And I went up to 4, I went up to 5, and I went, there's no difference. This isn't harder. And I concluded that this would work at 4,500. And I turned out to be right, which is great. So the reason this is very, very important, if you are trying, let's say you learned a new video, right? And you're trying to figure out patterns and analogies in it. Right now, if you analyze the new video, you have 3 possible things that you could snap to. That's really bad. What are the odds that like those 3 things actually contain this really weird abstract pattern you're trying to find? Pretty low. However, if you have thousands of really complex objects, the odds get much, much, much better. It could be that 1 out of every like 20 patterns you find, you've actually seen before. And if you've seen it before, you will get that pattern and analogy right away. You'll just snap to it. So
that would encourage continuing with this kind of practice to build those nodes.
Entirely. Some things you can do with the Atlas when you get practiced at it are encode things in real time that are super, super complicated, and then do this multi-system synthesis task across like 16 things, like I did in my demo. And you've now experienced the control task, and it's hard. I've had very like kind of the smartest friends I've been able to ask to do this, which happens to be my smartest friends. And they have tried this task, and they said it's hard, and they did poorly. With the Atlas, you can actually do that task. And you might ask, why does that task matter? It is a kind of a direct measure of fluid intelligence, and it's what you need to like excel in scientific fields, to like find patterns and deep connections among like 16 huge topics. So that is a little bit of the Atlas. There's so much more. I like discovered an amazing new thing about it pretty much like every day for the past 6 months. But that's as much as I can share concisely.
Interesting.
In like an hour and a half.
It's funny. I have an image in mind. I guess I probably do operate this way. I think when we first met, you asked, I can imagine my actual hometown where I grew up in very much detail. But I think of like when you talk about the snapping, I think about the Matrix when Neo says, "Hey, I know Kung Fu," right? They load it into his brain. It's a little bit like that. Right?
Yeah.
That's kind of interesting to use that as a metaphor for what's happening.
That is. Yeah.